Hello everyone, welcome to my first video. In this video, I'm going to solve this leetcode problem, which is add two numbers. The complexity of this code is going to be medium, and the problem says, you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero, except the number zero itself. So let's look at the number. In the first input, which is linked list number one, we have 2, 4, and 3, but they are in reverse order. So the right number, it's gonna be this one. It's gonna be 342. And the second linked list is gonna be 5, 6, and 4. But also, this linked list is in reverse order. So what we have to do, we have to, to reverse that linked list. So the result, it's gonna be this one. It's gonna be 455, right? And we add these two numbers together, the result, it's gonna be 507. So that's the result, okay? But let's analyze how so we're gonna return that output. They don't want us to return the output just like this. They also want us to return the output in reverse order. So we're gonna return first 7, later we're gonna return 0, and later we're gonna return 8, right? We have to do so. But maybe you're thinking, okay, what I'm going to do, maybe I'm going to reverse the linked list and sum those numbers and later reverse the result. Maybe that could be a great example, but let's think in a better way. What we could do is that maybe we have to go and travel in time and go back to elementary school. When they told us when we have to sum numbers, for example, I'm going to use this. When we have to sum 342 and when we have to sum 465, what do we used to do? We used to start from right to left, isn't it? So 2 plus 5 is equal 7, 4 plus 6 is equal 10, but we don't put that 10 over here, right? What we do is what you used to use something called a carry, or carry used to be 1, isn't it? So now 1 plus 3 plus 4, it's gonna be equal what? It's gonna be equal 8, right? And that is the result. Yeah, we did it. But now we have to start this in what way? So maybe you're seeing now the answer. First, we started calculating this 7. And this 7, it's gonna be stored in our first element of our result linked list. Later, the second element, and after this element, right? So we actually have the answer. But what could happen? Let's see. I'm gonna erase this. What could happen if instead of having a 4 here, we have a 9? So I'm gonna change this to 9. Sorry for the number, but it's gonna be 9. Hold on a second, I'm having a trouble here. Yeah, okay. So now we are gonna have a 9. So we already have a carry here. 1 plus 3 plus 9, it's gonna be equal to what? So do you have the answer? Yeah, I maybe sounded kind of stupid, but it's 13. Yeah, because I want to feel you that you feel empowered, that you really now are understanding the problem. So we're having 13, but we are not going to start that final number here, right? So we are having our 7 here, we are having our 0 here, but now let's imagine that here we're gonna set what? 13? No, that's not correct, because we cannot set two numbers in one because the problem says that only one. So what we have to do is to create another linked list and here set 1. So this is going to be 3 and this is going to be 1, right? So that's something that we have to do. So now that we are having the right answer to this, we have analyzed the problem. So now let's code this problem and we're going to call it all along. You know, this is my first time that I'm doing something just like this. I have never done something just like this before, but now we analyze the problem. So let's code it together. Okay, they are giving us here a class list node, and I used to read, well, I used to read a lot of data structures and some tips that they gave us. And in order to solve this problem, we're going to use here a carry because carry is going to be equal 0. But before we do so, what we have to do here is to create a new linked list. And how we're going to create that new linked list? Because we're going to use a dummy node. And this dummy node, it's going to be so helpful because it will help us to not go through edge cases. So our dummy node is going to be equal to list node. Okay, now we're having it. And now our current node, because remember that in a linked list, we have to traverse all the linked lists. We have to visit every single node in order to get the numbers. So our current number, it's going to be equal to dummy. Okay, so we're having dummy, we're having the current, and we're having the carry because the carry is important and it's going to be initializing 0 because here let's imagine that this 0 doesn't exist. So okay, now let's get started. They're giving us 3 inputs, which is linked list 1, linked list 2, and sorry, it's not 3 inputs, it's just 2. Okay, so what we're going to do, okay, we're going to use, what do you think that's better, a for or a while loop? In this case, I guess that it's better a while loop. Okay, so while linked list 1, it's what? We want to see that this linked list exists, isn't it? If linked list is not equal to none, continue. Or we want to see if the second linked list exists, or if linked list 2 it's not equal to none, okay, or if carry it's not equal to 0. Why to 0? Because if our carry it's not equal to 0, it means that we are having also numbers to be adding, like in the last situation that I explained. But if carry is equal to 0, it means that we don't have any more numbers to be adding in our linked list. So let's get started with our code. Well, let's continue with our code. It's better. Okay. So now our linked list 1 value, it's gonna be equal what? It's gonna be equal to linked list val, the first value, but that value will be only acceptable if L1 exists. If it doesn't exist, then return 0, right? Well, not return. Let's put 0 because L1 doesn't have any more values. The same for the other linked list. L2.val if L2 exists, else also return 0. So we're having that. But now let's continue with our sum. Where we are at, let's call this at. Well, no, better let's call this plus. Sorry, plus, because we're adding those numbers. So L L1 val plus L2 val plus what? Plus our carry, right? So we're having the answer. Let's look at this. 2 plus 5, it's equal 7. Yeah, that's perfect. But what happens if we add 4 plus 6? That's equal 10. What we can do. So let's use some maths. Remember that computer science field, it's logic and it's also being used in maths and no terrifying maths, also basic maths. So if we're having, for example, taking in example 4 plus 6, we know that 4 plus 6 is equal what? It's equal 10. But we are also having here a carry and a result. So what will be our result? Our result, that the result is the one that it's going to be put in their node, it's going to be equal to 0, right? And the carry, it's going to be equal to what? To 1, isn't it? So, so what we have to do now, it's how the hell I got that 0? That's really easy because the actual result, or let's call it digit. I think that's better. That means that's the digit that we're gonna put there. So digit, it's gonna be equal to what? To or plus, but we only want the leftover. Yeah, I know, the thing that was left. And how do we get that? With this operator, right? We're gonna have it without the digit. And the carry, it's gonna be equal to what? Carry, it's gonna be equal to plus, and we only want the not decimal part, we want it to be an int. So between 10, right? Isn't it? So now I have explained that. So our digit, it's gonna be equal to plus module 10, and our carry, it's gonna be equal or plus integer part of 10, right? So we're ready. We're almost done, but we're not done yet. Now we want to save this digit in a new node. So what we're going to do is so that we're going to create a new node from this carry node, and we're going to put list node. We're going to save that digit. And after that, after we have that digit, what other thing we're going to do? So now our current dot next, it's going to be equal to new node, right? Okay, so we're having new node, it's equal to this node or current next. Okay, so now our current, it's gonna be equal to new node, right? So because we're having new node, we're adding this digit, which is gonna be 0. Our current next is gonna be equal to a new node because we are not having another element, and because it will point to another node, and our current, it's gonna be our new node, the new node that we just have created, okay? So we're almost done, almost done, because we're gonna continue looping through all of this, but we cannot return that result because we're going to have an edge case, and I want to see if you're seeing it. What's gonna be our edge case with this? Because we want to see if we want to move now L1 and L2 to the next pointer. So we're gonna do, it's L1, it's gonna be L1 dot next if L1 exists, else none, right? L2, it's gonna be equal L2 dot next if L2 exists, else return on. And now that we're having that, because this will be our conditions in order that we can visit all the nodes, what we have to do here is now return. Sorry, my indentation is bad. Now here we're gonna return. What we're gonna return? We're gonna return domi.next. Okay, so now let's run our code and let's display that everything's okay. Yeah, our answer was accepted. Now here comes my favorite part, submitting, in order to see if our code is right. And yeah, it was a success. So I hope that you have understood this problem, and I'm gonna be adding more videos like this because I want to practice and I want that you practice along with me. So goodbye, and I hope this video has helped you. See you later.